matter? Molar mass is grams. Same thing. Something else.
It can be converted to molecules.
Okay, so you're saying particles, right? So mole can be converted as particles to grams, which is molar mass. And Scott, give me another one. Say again? Molar volume, liters, right? Okay. So that's the whole. That's all the three relationships. You can go 1 step, 2 step, 3 step, 4 steps. Sometimes the dimensional analysis is a little long, but label everything and you're good. What's another big idea we talked about, Allie? Okay, so empirical formula is dealing with the simplest ratio. We've actually been writing empirical formulas for a good month now. What are those? What kind of compounds were we always writing in the simplest ratio? Say again? Well, potassium ions meaning, you mean like with an ionic compound? Like, remember we'd always take our subscripts and reduce? That's us writing empirical formulas. We've been doing that this whole time. Now we're starting off at a different point. We're starting with data and then we're moving from here. So empirical formulas are our simplest ratio. Molecular formulas are just the real deal, not simplified. It's just like, for example, glucose C6H12O6, not simplified, but we can determine its molar mass. We can determine a lot of things about that. There's one more that we talked about in between. Percent composition, right? Okay, so percent composition. Those are our three big ideas. Let's call this category 1, category 2, and category 3. Which one are you most confident with? Give me 1, 2, or 3. Throw them up like this, and you're on your fingers. Use your fingers. Most confident in. Okay, what are we least confident in? Okay, cool. Let's do a couple of these. You guys start 1, and then I'm going to do number 2 with you guys. But start number 1. If this stuff's on your desk, that's fine. I'm going to have you pass it up to me in just a second. You probably need a calculator, you need a pencil. Get yourself started on warm-up, please. So if you did not turn in percent hydrate simulation, you're going to turn that in to me today. Your empirical molecular formula things, keep those on your desk. I'm planning to look at them right now. From set 10, keep that on your desk. I'm planning to look at that right now. Otherwise, please just sit there and start your warm-up. No, just hold it for a second. You'll turn in when you get up. You don't have to water. Not yet, just pull it. Okay. Guys, please start the warm-up. You guys can turn stuff in the box for the end. It's fine. That's what the empirical molecular notes on top.
On Monday.
Okay. Today is the 16th, yes. It says find the molecular. It says find the molecular formula. It's invisible, but it's there. All right. Some of you guys don't have your EF and MF problems on your desk, so keep them out for me the whole day. I need to see them because I need to know that you participated in class on Monday. Okay. So let's hold ourselves accountable. Try to remember we are starting with dinitrogen monoxide formula. N2O. That's laughing gas. Who's ever gotten their tonsils taken out or something like that? You go to the dentist, and they give you this stuff, and it makes you feel really good and not so attentive, and you drool. Yes, that was me. My mother fed me a milkshake after I got my wisdom teeth taken out. And she thought it'd be funny to video me, and I'm just drooling. I'm like, oh my gosh, this is so good, but drooling everywhere. Okay, so let's take this laughing gas from 650 grams of dinitrogen monoxide to atoms of nitrogen. Okay, again, we're comparing apples to oranges here, right? So we cannot go straight there. There is no direct conversion. Matt, tell me how you would start. Remember, Avogadro's number is talking about particles. Particles come in 3 varieties: atoms, formula units, and molecules. Right now we're in grams. We cannot use Avogadro's. So, give me your second instinct. right? So we have to convert to 1 mole of N2O, and what's related to that? Well, look, you know, so this is your guide, right? You know you have to put grams on bottom, and that's what you said originally. You have to put grams up, guess what? N2O, because that's what we have to start with. So then what number goes here? The molar mass, right? So what's the mass of N2O? 44.02, so 1414 is 18 plus 16 is, what did it say? Okay, 44.02 grams. I don't have my calculator, I'm trusting you guys. So that's going to allow us to cancel out our grams of nitrogen dioxide, or dinitrogen monoxide. Now we're moles of N2O. This is where some of us might choose one path and other people might choose another path. James, what path do you want to take? Well, let's just talk about it. Tell me your thoughts. What do you know has gone bottom? Right, you absolutely have to take this and write it down here now. So mole of N2O. What can you directly compare to 1 mole of N2O that might help us get to our final destination, Scott? Particles, what particles? So, but what are the particles called for this? This is what kind of compound? Use your words. Molecular? It's a molecular compound. It's a covalent compound. Okay, so we're converting to molecules. Took the words right out of your mouth. Okay, so we're using Avogadro's number to convert to molecules of N2O. Okay, so we have this big, huge amount of N2O. We've narrowed it down to just a bunch of molecules. We pick one molecule out. Now we're going to kind of organize our thoughts into a Lewis diagram in our head. We know what it looks like. We can see the subscripts. Now let's go down to one molecule, because you can see molecules of N2O have to go on bottom because they guide you to your next denominator. One molecule of N2O. What do I want to convert to from there, Niall?
Convert to nitrogen.
So I'm going to call it atoms of nitrogen, right? So how many atoms of nitrogen are in one molecule of N2O? How do you know that? Subscript of 2. This is right here. It's telling you there are 2 atoms of N. So using your words appropriately, right? 2 atoms of N, nitrogen, in that molecule. And I think we're good. Our moles of N2O cancel. Our molecules of N2O and molecule of N2O cancels. And we're to atoms of nitrogen. Okay, so you guys math it up here. Did I bring my calculator? Anybody have the answer? The 100. Did anybody else get that? Okay, good. Majority rules, atoms of nitrogen. All right, so that is the most complex. I will make it on the quest tomorrow. I'm calling it a quest because it's a little bit more than a quiz, but it's not really a test. So it's a quest. Okay? So, does that make a little bit more sense? We remember our relationships. We'll kind of dive into those some more, though, okay? So let's hit the empirical molecular formula debate. We are using percent composition. We are told we have 40% carbon, 6.7% hydrogen, and the rest oxygen. So what's the rest? Do the math. So this is 46.7, so 100 minus 46.7 is 53.3. Okay, are we all comfortable doing that percent? At least get that far. That gets you partial credit, 1 point, okay? The molecular mass, or the molecular formula mass, is 60 grams per mole. It's probably asking us what's the molecular formula. It doesn't say it. How do you guys want to start? You went through your process. Let's review that process real fast. If I start you off in percent on the empirical formula, the very first thing you do is assume. Okay, so we assume 100 gram sample. Why is that important? Why is that helpful? Right, you can assume 100 gram sample, and you go, okay, 100 gram sample, 40% of 100 is 40, and then so forth, right? So let me scooch this down so I have some space to write. Okay, so you assume 100 gram sample. That means in your head you're just going 40%, 40 grams is carbon, and 6.7 grams is hydrogen, and how much oxygen? Good, 53.3 grams of oxygen. Notice these are just single atoms. We're just writing in their elemental form. First step, assume 100 grams. Second step, go what? Go to moles with using molar mass. We're multiplying by molar mass or using molar mass in our conversion to go to moles. And that's moles of just the atom, just the element here. So, what are you looking up for carbon? Maybe you don't have to look it up at this point. You've used it probably numerous times. What's the molar mass of carbon? Okay, does it go on top or bottom? Bottom, right. So 1 mole of carbon, we're converting 2 moles. Moles goes on top. 12.01 grams of carbon is the molar mass. And then I'm going to go ahead and write the other ones, and we'll calculate all at once. Molar mass of hydrogen, 1.008 grams of hydrogen. And oxygen, 16.00 grams, 1 mole. Okay, so everybody can set up molar mass. We can use this now for empirical formula and molecular formula. What is the number of moles of carbon up here? Peyton? 3.33 moles of carbon. Melanie, next one. 6.7 divided by 1.008. You ready, please? Did you do 6.7 divided by 1. It's 1.008. Great, of hydrogen. And then, Abby, oxygen here. Okay, so we've successfully taken our percentages to grams by assuming 100 gram sample. We've converted to moles. Those are our first 2 steps. Third step? Alina? Divide by smallest number of moles. Okay, what's our smallest number of moles, guys? 3.33. We can do this in our head. So divide by 3.33 on every single one. And it doesn't seem like we're gonna have a problem with rounding. Should be full integers. So what's the first one? 1. Second one? 2. Third one? 1. So these numbers are what now? They are subscripts. They are describing the relative ratio, which is just the subscripts of each of these atoms to each other. So don't forget, these are subscripts. And what would the formula of this guy be then? The empirical formula is C what? CH2O1. So C1H2O1. That's the empirical formula. Can we quickly figure out the mass of that empirical formula? Go ahead. How much?
30.026.
So 16 plus 2 is 18, plus 12 is 30. So I'm going to go with just straight 30, okay? So that's about 30 grams per mole. So 1 mole of this EF, empirical formula, whatever the thing's called, that's formaldehyde. It's 30 grams. Why is that important for us to know? So we can go to the molecular formula. The molecular formula comes in full repetitive or multipliers of this, right? So you can see the relationship. If this is 30 grams, this is 60 grams. How many times is 30 going to 60? Twice. So 2 times would mean us distributing a 2 to each of these integers or multiplying it by each of the subscript by 2. So what would the MF be? C2H4O2. Great. That's an organic structure of some sort. There's no need to try to name that one. Anything that you're comfortable with naming, you should be able to name. Like you had some of them on your problems from last time. What were some of the names of the formulas you got for your ionic ones? Look at your 4. I think I selected 5 in the video. I selected 4 in the video, and I said you guys choose 2 more. What were some of the names? Aluminum what? Aluminum phosphate, right? AlPO4, that was one of your empirical formulas. What's another one? Sodium sulfate, Na2SO4? Yeah? What's another one? Potassium what? Chloride, is it KCl? Okay. And the last one, give me a name. I'm doing this from memory. Did you name the last one? Oops. What was the last one I told you to do? Oh, I told you to do this one, didn't I? Number 5? No, I didn't. Okay. number 4. Okay, I won't do that one right now. So the empirical process is pretty easy. The molecular process is just like one little tail end. We could divide and multiply. So that's why I usually with 3 steps, and then from there you can figure out if you need to multiply. You did on this one. Okay, let's do one more. And you guys tell me, I want you to think through the process in your head for 1 and 2. And then tell me if we need to do it. So I'm going to let you start with 1. Take 10 seconds and think about what process has to occur. Allison, what do you think? Nope. Okay, guys. Let's just have a heart to heart. If you want to use Avogadro's number, there's only 3 things that it could be referring to, right? Those things are considered the umbrella term. We call it particles. Particles are, again, Brandon, tell me what. Molecules, right? Think of particles as a thing. You're describing this is a thing. This is not a mass. This is not a mole. This is not a liter. This is a thing. This is a particle. I call it a scissor. I don't know what you call it. Okay, so if we're talking about a covalently bound compound, we're going to call them molecules. If we're talking about ionically bound compounds, we call them formula units. And if we're talking about an element, we call them atoms. So those are things. Those are particles. Those are matter. Okay, those are terms you've heard before, but now we really conceptualize them. So I'm not going to use Avogadro's number here. I'm going to use what instead? The molar mass of calcium chloride. Formula calcium chloride. Go. Cl2, calcium's got 2 charge. Okay, so I'm walking through process. You're taking moles to grams. 1 stepper, we're done. Okay, look at number 2. 10 seconds or less, you should be able to tell me the process. Teresa, what do you think? Yes, because what are we starting with here? Yeah, we're starting with a form of a particle. We're starting with formula units of sodium phosphide. What's sodium phosphide? Think about it. Ready. And I hear P. Stop. Do not say, okay, but where's the 3 going? Okay, Na3P. That's not phosphate. Phosphide is an easy one because pressure charges. Okay, so we're starting with formulas, and then we're doing what, Teresa? We're using Avogadro's number to go to what? So Avogadro's number goes with the particle, so we'll do this. I'll write this out for you. 6.7 times 10 to the 22nd formula units times what? Right, so we're going to moles is what I want you to tell me. We're going to moles on top, and then Avogadro's number down low. So I'm just going to put A number, Avogadro's number. Okay, also a single step, right? Okay, so no, so good so far. Now, we have a third one. Think about this one. Who's got me here? Melanie. So and how do you know that? Okay, so you know we're starting with the molecules. So we're starting with molecules, going to moles with Avogadro's number, and then, okay, good. So then we're going to grams. So the first conversion, I'm just writing this in mini forms, okay? This is Avogadro's number. We use for molecules to moles, so particles to moles, and then for moles to grams, we're using the molar mass. Good. And then the last one's an empirical formula. So this is a single step using the molar mass relationship, molar mass meaning moles and mass. The second one is a particle relationship with Avogadro's number and moles. The third one includes them both. The only one that's not really present is the molar volume one, which uses what number? 22.4 liters per 1 mole. Right, it's always related to 1 mole. Don't do crazy. I'm like, I think that's 6 moles today. Okay, so let's finish kind of concluding on problem section when you guys get back to here from the CSI investigation. Dun dun dun. Okay, so well, here this is. Okay, so you guys have to wear a badge so I know who my liaison is. I am your captain. I have a forensics degree. I know, I'm just joking. But You guys are going to be choosing one person to be your liaison. You can come and ask the captain some questions, but we have to solve this death. There's a man dead on the floor back there, like this. Okay? There's some tape. Be careful. But he either died by medicine exposure. Hold on, I'll tell you. He either died by taking some extra medicine that he should not have, so overdosing. His wife killed him. She's really nice, though. I don't know. He also is a chemist, and his lab assistant may have exposed him to something that was lethal. I know, it was a dang lab assistant. And there's one more. Somebody, he ingested something, poison. Okay, so we have to figure out what happened. But you're going to figure out with your immense amount of chemistry knowledge concerning empirical formulas and molecular formulas. So you can only communicate within your table to make the best team win, more money. And make sure you're writing your name tag so I know who's going to be coming back across the tape to talk to me. Otherwise, you have to stay behind the tape. This should take us no more than 30 minutes to solve this problem. This person needs some justice. Okay? So you need to get in groups of 3. Get a piece of paper. Everybody's writing, and then I'll come and deliver a name tag to your group so I know who's who. Okay? In your problem set, in your EFN notes on your desk if you can. Let me find tape. Yeah.
Oh, leave it on your
Those where you see a piece of paper. Stand using. Groups of 2 or 3 should work, but groups of 3, I don't care. So you guys do not write on the paper, and please start reading the little excerpts so you can figure out how they died. I have the autopsy report, and that's how you will conclude your findings. You have to read the autopsy report. Everything pulled out. Use it. I have
Guys, if you not read the very bottom, it says find the EF and MF of everything because that's what you're going to be putting out. Okay, great job. Okay.
Oh, I thought you said.